Question 3 says student A investigated how current in resistor R at constant temperature varied with potential difference across the resistor. This statement is important because it tells us that we will change V and we will record current at constant temperature. It then says student A recorded both positive and negative values of the current. Again, this statement is important because it tells us that we'll have to reverse the terminals of the battery so that you can have positive and negative values of the current. Then says figure 2 shows the circuit student A used. Now this circuit is a very important circuit. Every single time you have to investigate the resistance of a component, you will always make use of this circuit. And it is only this section that will change. The remaining section will always remain the same. So let's quickly have a look at this circuit. This is a series circuit. I know this is my variable resistor. And I'm going to call it Rx. And I know because it's a variable resistor, the value of Rx can be physically changed. So it's a series circuit. The total resistance will always be Rx plus R. Now, based on this information, I can analyze this circuit and I'm going to say if Rx increases, then what will happen to the value of RT? RT will increase. If the value of total resistance of the circuit increases, that means the value of the current will decrease. Based on this change, we now need to look what will happen to the values on these two meters. So I'm going to say the value on the ammeter will fall. That's obvious. We have to be a bit more careful with this value. The job of this voltmeter is to determine the amount of energy that this resistor is receiving. The total energy is from here. Some energy will go to this component and the remaining energy will go to this component. If you increase the value of Rx, then this component will receive more energy. As a result of this, this component will receive less energy. Now, in this case, we have said our Rx has gone up. So this means our Rx will extract more energy. Therefore, the value on the voltmeter V will fall down. So this is extremely important. If you've understood what I've just gone through, then this means you will be in a very safe zone when it comes to answering questions like these in your exam. There's an equation for this circuit that links these three variables: V, which is potential difference across R, resistance of this resistor, and the current in the circuit. That equation is V equals I times R. If I rearrange this equation, I'll end up with R being equal to V over I. And this is our main equation to determine the value of R. Now here it says describe a method that student could use for this investigation. What we need to do is we need to record the value of current. Once we have changed the value of V. To change the value of V, we will have to adjust the value of R here. So the first thing that I will talk about is I'm going to say record value on voltmeter. Number 2, I'll say record value on ammeter. Number 3, I'll say change Rx and repeat 1 and 2. So up until this point, it will give me all the values of current, which will be either positive or negative. Because the question says they recorded both values, positive and negative, for the current. I will now say reverse terminals of power supply and repeat 1, 2, and 3. Number 5, once I've got the values of V and I, I'm going to say plot graph of I against V. And when you plot this graph, it will be a straight line because it's a resistor. To get the 6th mark, I now need to mention about the precaution that will allow me to keep the temperature constant in R. So for that, I can say use small currents, or I can say switch off between values. These both are to keep temperature of R equals constant, because we know that if you use current, which is large value, then what will happen? It will cause heating effect, and as a result of that, the temperature of the R will change. Next part says student B repeated the investigation. During student B's investigation, the temperature of the resistance R increased. We know if the temperature increases, then the resistance will increase. Now it says explain how the increased temperature of resistance R would have affected students B's results. So if the temperature increases, then we know the resistance will increase. The first thing I'll say is temperature increases, R will increase. Number 2, I can say therefore graph will not be a straight line. This generally happens in filament lamp. And that's why when you plot a graph of filament lamp for IV, has a shape like this, because the resistance is changing. It is not constant, so it is not a straight line. Next part says figure 3 shows the scale on a moving coil emitter at one time in the investigation. What is the resolution of the moving coil emitter? Resolution. So the resolution is smallest increment. So what's the smallest increment in this case? I can see there are 5 gaps between 1 and 2. So each gap is representing 0.2 amps. Last part on this question says student B replaced the moving coil emitter with digital meter. Figure 4 shows the reading on the digital emitter. The digital emitter has higher resolution than the moving coil emitter. This is advantage. Okay, so we've got two. This is also advantage. So we got 2 advantages of this. Give one reason why it would have been better to use digital emitter through this investigation. So I can say the first one, because it's digital, so I can say there is less chance of misreading. Okay, then high resolution has advantage as well. I can say this means the recorded value is more close to the actual value.